Okay, so today it is our last part of our lecture, Doppler effect, swing of sound. That means the beginning from the end, right? Okay, so just write topic name, Doppler effect. Doppler effect, swing of sound. That means beginning from the end. It is a very special case, beginning from the end. Beginning from the end, right? Okay, so it is just recall our last part of the lecture in this previous lecture. Just I have introduced to you Doppler effect, right? A story of a train and a man who is just standing on a platform and a sound like Sare Gama Pada Nisa, right? Just a story of a train and a man who is standing on a platform, right? If it is a platform and if a man standing on the platform and if a train is moving towards the man, right, with somehow 60 meter per second, the speed, the 60 meter per second, and if the initial separation between the platform and the train is 3000 meter, and the speed of the sound, I just take speed of sound is a 300 meter per second, and if the train produces sound like Sare Gama Pada Nisa each and every 5-second interval, right? I mean, if the train is actually, when the separation in between the trains and the platform is 3000 meter, then if it produces a sound like sa, then after the 5-second interval, when the train reaches this point, I mean, just 5 seconds and the speed of the train is 60 meter per second. So obviously it crossed a 300 meter, and then it produces a sound like rain, right? Just a 5-second interval of time, and then after a 5 second when the train is here, then it obviously crossed another 300 meter, and then the train produces a sound like ga, right? So the time interval in between sa to re to ga, the train is actually 5 seconds, but this sound pulse, I mean the sa re ga, appears to the man actually who is standing on the platform. It is a 4-second interval of time. Just I calculate in previous lecture, right? So if it is a 5-second interval of time, then here the sa, re, and ga just appears to the man is a 4-second interval of time, right? Just I calculate previous case in previous lecture. Okay, and henceforth I just draw just formula in the Doppler effect, I mean the frequency formula of the Doppler effect. Okay, so if it is a delta t, if I take a delta t dash, I mean the time gap in between sa to re and the re to ga, the delta t dash, and here is the delta t, the time gap in between the two sounds sa to re to ga. Then we just ended off the very crucial formula, that means a delta t dash actually a delta t times 4 by 5 actually. The delta t dash means the time gap in between two sounds at the position of man, and the delta t means the time gap of two sounds in the train actually, right? Is a 5 second, is a 4 second. And then I just crossed some process of dimensional formula, and just the factor 4 by 5 just depends on the speed of train and the speed of sound. Then after just crossed some mathematical form just a dimensional formula, then we have ended up with the frequency of a sound at the position of man is actually a frequency of the sound at the position of the train actually f divided by 1 minus speed of train by speed of sound, right? It is actually our previous calculation of our previous lecture, right? It is a frequency formula and the Doppler effect. It is actually a Doppler effect. Okay. Okay. So today we will just introduce how the frequency will change and how the time gap will change in some another speed, right? Another speed of train. Just magical formula, just taking here. It's a f dash equals to f by 1 minus pt by vs, and the delta t dash, that means time gap between two sounds at this position, the delta t here, the time gap in the train here, and it is a relationship, right? Okay, it is our previous calculations that are from our previous lecture. Okay, so now just imagine if the speed of the train is the same with the speed of the sound, right? Then what will happen? If the speed of the train is the same with the speed of the sound, that means if the speed of the sound is 300 meter per second, then if the train moves 300 meter per second, then what will happen? Speed of this train is 300 meter per second. Then what will happen? The train produces the sound like sa re ga ma pa dha ni sa. It's no problem. But what will happen at this position? I mean the time gap between two sounds at this position, I mean at this platform. What will happen? So let's check. It should be, I mean, it will be a very interesting results, right? Just check. Okay, so first of all, the speed is a 3000 meter here. Initial separation between train and the platform is a 3000 meter, and at this position the train produces a sound sa, right, at the 10 a.m. just exactly at 10 a.m. right? When the initial separation between platform and the train is 3000 meter, and the speed of the train is similar to the speed of the sound, 300 meter per second, then it produces a sound like sa at just 10 a.m. right? Okay, so now after 5 seconds, obviously after 5 seconds the sa actually traveled the speed of the sa and the speed of the sound is actually 300 meter. So after 5 seconds the sa actually traveled s, I mean the distance traveled by the sound actually v into t. So the speed of the sound, I mean the speed of the sound is actually 300 meter, and the time is 5 seconds. There is a 1500 meter, right? So after 5 seconds, the sound actually, I mean this pulse of sound travels 1500 meter. I mean from here to there, 1500 meter after 5 seconds. And obviously, if the speed of the train is 300 meter, then obviously the train will travel same length. Okay? Because the speed of the train is 300 meter and it takes 5 seconds. So it covered the distance is actually 1500 meter. Right? It's very simple. So when the psi is here, then the same position the train is here, right? Same position with the psi actually it named psi, and the train is here. After 5 seconds, it travels the same length actually, and then it produces a sound like ray, right? Because the train produces the sound each and every 5-second interval of time. Then it produces ray. Okay. So ray here produced, sa here produced 10 am, and on the 5 seconds, after the 5 seconds, the sa travels 1500 meter, and the train will travel the same length, and then the train produces sound like ray. Okay, at the 10.00.05 second, right? Okay, but just imagine when the psi is reached here, then the train is reached here, just same, and then train produce the sound like ray. Now the psi and ray is the same position and travels with the same speed, right? The psi and ray is the same position and travels the same speed, and obviously it is a very simple. Psi and ray actually appears to the man simultaneously, right? Psi and ray appears to the man simultaneously, because when psi is here, I mean the 1500 meter from here, then the ray produced by the train. So the ray and sa is the same position, and then it moves ray and sa simultaneously. So obviously the ray and sa will appear the man here simultaneously. I mean the time gap in between ray and sa is actually 0, right? Because the psi and ray appears here just simultaneously. Because when the psi is here, then obviously ray produced by the train is here, just same position, and obviously ray and sa will travel same speed. So obviously these two sounds appear to the man just instantly, I mean simultaneously, right? The time gap in between two sounds here is a 0, but the time gap here is actually 5 seconds, right? Delta t is actually 5 seconds. Okay. So if the delta t is 0, so what will be frequency? Delta, I mean the frequency f dash, obviously 1 over the reciprocal of delta t dash, that means somehow 1 by 0, that means infinite. Okay, just infinite, right? I mean there is no time gap in between two sounds at this position, right? So if the train moves the same speed with the sound, and if the train produces the sounds like sa, re, ga, ma, then obviously these all the sounds appears to that man in the same time, just the instant of time, just a snap of the time.
is the collapsing of that all the sound, right? So it is a collapsing. All the sounds collapse with the snap at that position, right? All the sound will appear at the same time. Okay, there is no time gap, just a collapsing of all the sounds, right? It is very simple. The man actually hears all the sound in just a snap, I mean instantly. All the sounds appears to the man simultaneously, right? There is no time gap. Okay. So do you see the equation here? Very simple case. Now it is now I'll introduce a very special kind of movement of the train, right? So just consider it's not a 3000 meter the initial separation, because for simplicity just consider a train moves towards the man and the initial separation in between the train and the man is actually 6000 meter, right? Initial separation between train and the man is actually 6000 meter, and the train moves with a speed somehow larger than sound, greater than sound. Then what will happen, right? Then what will happen? These are just the last thing, beginning from the end. I mean the swing of sound, right? Just the swing of sound. Okay, so obviously the train produces sound like sa re ga ma pa dha ni sa after each and every 5-second interval. But what will happen here? These are main, just the main concern. What will happen here? I mean at the position of platform. What will happen? Okay. Okay. Just think, if the speed of the train moves towards the man, and if the speed of the train is just 360 meter per second, 360 meter per second, I mean it's greater than the speed of the sound, right? If the train moves 360 meter per second, I mean the greater than the speed of the sound, then what will happen? Okay. Okay. Okay, so let's check when the initial separation between the platform and the train is 6000 meter, then the train produces a sound like sa. Okay. 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 Then after 5 seconds, the speed of the sound is actually 300 meters. So the sa travels S, the distance traveled by sa, actually speed of the sound and the time taken by the sound to cover the distance is 5 seconds, is the t. So it is 300 into 5, that means 1500 meter, right? So after 5 seconds, the sa actually here, the sa travels 1500 meter, right? From here to there, 1500 meter. But the train covers somehow a larger distance, right? Because the speed of the train is greater than the speed of the sound. So the distance covered by train actually V into T is the distance covered by train, ST, right? The speed of the train is actually 360, and the time taken by the train after 5 seconds actually is 360 into 5, that means 1800 meter. 1800 meter. So after 5 seconds, when the sa actually 1500 meter from here, but the train crossed sa and it is here, right? Train is here I mean 1800 meter. It is actually 1800, right? So it is the sa. When the sa is actually here, 1500 meter from here, the train is actually here, that means 1800 meter from that position. Okay, because the speed of the train is somehow greater than the speed of the sound. Then it produces a sound like ray, because obviously the train will produce the sound with a 5-second interval of time. Okay, so when the train is there, it sounded, I mean it produces a sound like sa, and after 5 seconds when the train is here, actually it produces a sound like ray. Okay, but problem is that the ray is actually ahead of sa, right? Because the sa travels 1500 meter after 5 seconds, and when the ray produced, the train already covers 1800 meter, right? I mean the train is actually ahead of the sa, and obviously when the train produced ray here, then obviously the ray actually ahead of sa, right? So obviously these are ray, these are ray, and these are sun, and obviously, hopefully, you will understand the ray actually appears here faster than the sun, right? Because the ray actually ahead of sun, the ray actually is ahead of 300 meter from the sun. So the man standing on the platform will hear firstly ray, right? So ray, then after sa, because sa is actually left here, ray is actually ahead of sa, right? Ahead of sa. So the ray will appears here, the ray will comes here the faster from the sun, right? Because the ray is ahead. So the ray is the sound and sa is the sound. So the ray actually comes faster from the sound. So actually the man standing on the platform will hear first ray. It's not a sound, right? Okay. And then after 5 seconds, the train is actually traveled another 1800 meter. S of train is a V into T. Speed of the train is 360 and time is 5. So 1800 meter, right? So then after 5 seconds from the producing of ray, the train will travel another 1800 meter. Okay, another 1800 meter. But there is a problem, and a train actually, when it is from after 5 seconds, it is from here to there, and after 5 seconds from here to there, it produces a sound like ga, right? So when the ga is here, then what is the position of ray and sa, right? So obviously ray means a pulse of sound, sa means a pulse of sound. So the sa is here and ray is here after 5 seconds. Then after 5 seconds, I mean another 5 seconds, the sa will travel the same. I mean the speed of the sound is 300 meter, and the time taken by sa is 5 seconds. Then obviously the sa will travel another 1500 meter, right? So here the sa will travel another 1500 meter, 1500 meter from here to there, right? Is a position of sa, and after 5 minutes it traveled 1500 meter, and it's the position of the ray, and the ray will travel another 1500 meter, right? I mean from here to there, from here to there, 1500 meter from here, right? 1500 meter. But the train actually traveled 1800 meter, right? So actually the ray is actually ahead of Sa, which is the Sun, because it is in the position of Sa. Sa traveled 1500 meter from here, and the ray will travel 1500 meter from here. It's a Sa, it is our Sa, and it is our ray, right? It is our Ga. But just observe carefully, the Ga is actually ahead of ray and the sun, right? Because the train traveled 1800 meter from here, ray will travel 1500 meter from here, and the sun will travel to 1500 meter from here, right? So the guy is actually ahead of ray and sun. So obviously the ga appears faster from ray and sun. So the man actually hears the sound, the ga and ray and sun, right? Because the ga is actually ahead of ray and then sun, right? It's a sun, it's a ray. So the guy is actually ahead of ray and sun. So the guy is actually comes here faster. So the guy is here 1. Then it is a turn of ray 2, and then it is a turn of sun number 3. So the man actually hears sound like ga re sound. Okay, that is a reversal of time. The train produces the sound sa re ga, but the man actually hears the sound like ga re sa, just the reverse, right? So if the train produces a sound like sa re ga ma pa dha ni sa, then the man who is standing here hears the sound like sa ni dha pa ma ga re sa, just a reverse case. So it is actually a beginning from the end, right? It is actually a beginning from the end, just a reverse case. Okay. So if the speed of the train is somehow faster than the sound, and if the sound produced by the train like sa re ga ma pa dha ni sa, then the man who is standing on the platform hears the sound like sa ni dha pa ma ga re sa, just a reverse case, right? It is just a name, the beginning from the end, and the swing of sound. The sound is just a swinging, right? Just a swinging, the beginning from the end here. Okay, so, and I have just one question about on you, I have just one question. Is it true for the case of light? Is it true? I mean, if a man at the train is watching the movie from first to last, then is it possible at the man who is standing here to watch this same movie is the last to first? I mean, just reverse case. Is it possible? Okay, so it is our question. Just think about this question. Okay, so is it possible to watch this movie from first to last? Okay, It is our end of the lecture. The Doppler effect, swing of the sound, and the beginning from the end. Okay, and then in the next lecture, I'll return back to our vector series in the vectors for down. Okay.